Right, hey guys, here is 1.4. I'll apologize beforehand if there's background noise or the fan. I am in the school, so there might be unpredicted noises, so I apologize for any of that. But here's 1.4. We're rotating a line segment AB about point A forms a circle with circle A. Okay, how can you use a similar method to form a cone using the triangle shown? Okay, so it told us that if we had a line segment AB and it rotates around point A to form a circle with center A, you could do that. You just rotate and you form a circle. Right? So that's kind of what I'm talking about. That's more of an oval, but best circle I could draw. Now it wants you to take this triangle, take the same exact idea, except we're going to, if I wanted to make a cone, instead of rotating it maybe left or right, I'm going to rotate it in a circle around line L. Okay? Because if I were to swing this triangle around, it would create a cone, right? Okay? So you can see part of the triangle lies inside the cone. Once we swing it around, it becomes 3D shaped cone. Okay, example 1. Sketch the solid produced by rotating the figure around the given axis, then identify and describe the solid. Okay, so we're taking the same exact idea as our starter, our warm-up thinking. And if I'm rotating it around the given axis, the axis is always just that line it lays on. And rotating it around the axis, that means I'd rotate it kind of this way, curved, it'd swing around. Now if you visually think about it in your mind, that tells me I'm going to create a cylinder. Because part on that cylinder, I'll have a rectangle side, and when I swing it around, you create a circle top. Just like in our previous example, rotating that line around creates a circle. Rotating the top of the rectangle creates circle top, so we now have a cylinder. Okay, and then we rotate this one around our given axis. Same as our first example, it's part triangle rotating around our axis. It's going to give me a cone. And we know once again rotating our straight line in a circle, it creates a curved surface. So circle at the bottom giving us a cone. You might think you get a pyramid, or on part A, a prism, but if you notice swinging a line around, it creates a circle, the edge points. Okay, example 2. Most bases are solids of revolution. Sketch a two-dimensional shape and an axis that forms this base. Okay, most solids you can create with an axis and a 2D shape. Most of the time you can create them, they have to have some sort of line of symmetry though. So if you have a 3D shape that's kind of all over the place, just all ski-wompy, and it's 3D, it'll be hard to create a line of symmetry or an axis of revolution for that. But if I look at this solid here, this vase, I do notice that we have a line of symmetry. So you'll identify a line of symmetry, and then you'll take half of that shape where it's symmetrical, and we will trace it around our axis. We'll do our best. Won't be perfect here, but there would be our vase. Then if I swing that around my axis, the end result would be my 3D shape. Right? So find a line of symmetry, and that's where you put the half of it, the side that reflects, on your axis, rotated around to get your 3D shape. Okay, example 3. Sketch and describe the solid produced by rotating the figure around the given axis, then find its surface area and volume. Okay, to do this, obviously rotating around, it's a rectangle, and we've learned that that's going to produce a cylinder. Okay, the height of this cylinder is given on the dimensions of the rectangle, so height is 6. If we have a width of, height is 8, I apologize. If we have a width of 6 on our rectangle, wouldn't that be the diameter on our cylinder? Right, would. So diameter on our cylinder is 6, height is 8. we want to find the volume and surface area. Volume would be the area of the base. Space is a circle, so pi r squared multiplied by the height. And as I give these formulas, I typically have them memorized. But if you're stressing about these formulas, don't worry, they'll be given to you. So pi r squared multiplied by the height for the volume. And the surface area, you have 2 pi r squared for 2 of the circles, 2 of the bases. And then we'll add the outside. Now the length of the rectangle is going to be the circumference. You would think that it's 6 times 8 to get this or that outside piece, but we're going to have the whole circumference, that whole revolution. So if I were to open up this in a net, my cylinder, I have this which wraps around my circle, and we know the outside of circle is the circumference. Circumference equals pi times diameter. Our diameter is 6, so we'll do our 6 times by pi times by our height, because we'll need the height to figure out the rest of this area, the opening part that we're working with, which is 8. Okay, then to plug it in for our volume, we'll have pi. The radius of our circle is half of 6, so 3 squared multiplied by our height of 8.